this problem is very similar to the AP type question that we started looking at yesterday at the end of the period, in the sense that it's broken up into how many different regions? I see 2 regions. So here's what I want you guys to do. I want you guys to take the 2 different color highlighters that you have and highlight one region in one color and highlight the other region in the other color. Now, who can tell me the reason why we have to do this? Why do we have to break it up into 2 regions? What's different about this first region than the second in terms of what we were talking about yesterday? Good. The top function changes. Which is on top here in this purple region? Good. The cubic function, the red one, which is the cubic function. And which is on top here in this orange region? The quadratic function. Beautiful. So, this means how many integrals are we going to need to set up? 2. Do you remember enough of how to do that yesterday to do it on your own? Okay, try it on your own. So try to set up these integrals, try to put these functions into your calculator, and try to see if you can calculate the area. I'll give you guys a few minutes, and then I will go ahead and check your work. Alright, so I at least want to show you guys the setup of the integrals, make sure you guys did that part correctly. For the purple region, notice that the furthest point to the left is at x equals negative, is that negative 4 or negative 3? Negative 3, yeah. The furthest point to the left is at x equals negative 3, the furthest point to the right is at 0, and for the orange it's from 0 to positive 3. So notice that my integrals change based on which one I'm looking at. In the first one, the red function's on top and the blue's on bottom, so I do top minus bottom, so the cubic minus the quadratic. And in the second one, the blue one's on top and the red's on bottom, so I do the quadratic function, that's the minus, the cubic function. So, by raise of hands, let me see how many of you guys at least set up your integrals correctly. Alright, beautiful. If you did not, make sure you guys have what's written up here. And then I'm going to go ahead and do the problem as well so that I can check the work on a calculator, and I'll put the area up in just a minute. So here is what, I'll put a screenshot of my calculator up here so you guys can see what I got. Here's what I got, 81? Okay, beautiful. So notice that I did it from negative 3 to 0, and then I did not type in the actual functions. I put them into y1 and y2 so that I could just recall y1 and y2. Yesterday I was having people in my 5th period at least not do this, and I would suggest definitely doing it because you're much less likely to make a mistake if you actually type the function into y1 or type it into y2. If you actually try to type this out on your screen, on your home screen, number 1, it's a lot easier to make a mistake, and you just get more frustrated that way. And number 2, it just takes a lot longer, and it's harder to find a mistake if you do make one. So I suggest doing it like this. Put one of them into y1 and the other one into y2. The only thing you need to remember is that you remember which one you put into which, so you know which order to subtract them in. So I knew that for y1 I put in my cubic function, and for y2 I put in my quadratic, so I knew which order to subtract them in. Alright, so I got 81 as the final answer. So, whenever you have 2 separate areas that are blatantly in different regions, or blatantly separated by a crossing of the graphs or whatever, you have to set it up like this. Sometimes you also have to set up 2 integrals when it's not blatant or when it's not in your face. So let's look at an example of what you have to do when that happens. So let's look at example number 5 together. There we go. Example number 5 says, find the region bounded by these graphs. Y equals 12 minus x squared. Which color graph is that up here on my board, on my screen? That's the red one because it's an upside down quadratic. So it's an upside down parabola, which is the red one. Y equals negative x. Which color is that? The green one. And what about y equals 4x? The blue one. So it says find the region bound by these graphs. So look up here at my screen. Notice that this, and I'm going to trace it right here with this little green finger, that is the region. Okay, are there 2 separate regions? Not really. It doesn't look like two separate regions. It's not like one function crosses over the other function to create two different areas. It's all one area. It looks like a little random pizza slice. Can you guys see this little pizza slice kind of thing? Here's the problem. We do need to set up two integrals. Who can tell me why you think we need to set up two integrals even though it's not two separate regions? Go ahead. It's okay. It's the best.
The left side, the blue line, and the right side.
Good. It's because of this. What's the top function here in this region here? The red function, okay? And then what's the one that has the lower function, the one that kind of bounds it on the lower end? The green function, okay? But what about over here? It switches. Which one's on top over here in this region? The red, and which one's on bottom over here? Blue. Some people were confused yesterday. They wanted to use all of them. They said it goes red, then green, then blue. So they were subtracting red minus green minus blue. This part of the blue line down here has nothing to do with this area that's bound by these three curves here. So we're only looking at the lines that actually touch it in the region where we're looking for the bound. So get out two highlighters again. With one of your highlighters, highlight one of these regions. And with your other highlighter, highlight the other region. So even though it's all one region together, even though the regions share a common side, we have to treat it like two integrals to make sure that we can look at the correct functions. So I'm going to leave it up to you guys again. I'm going to have you guys do your part and see if you guys can set up the integrals and see if you can find the area of this region. And then we'll look at it together in just a minute. So try to write it on your paper. Here is the integral that you would use. So notice that we have a lower bound of -3, and then the yellow region stops at 0, the orange one picks up at 0 and takes us to 2. So a couple mistakes that I saw people making that I want to make sure you guys don't try not to make again and again. Number one, I saw a lot of people put this upper bound as 3 accidentally, so make sure that you get the upper bound correct, that it's a 2. I also saw a lot of people accidentally put this plus sign as a minus sign. So remember that this first integral is giving us the area of the yellow region, and the second integral is giving us the area of the orange region. So we actually want to add those together to find the area of the entire thing, not subtract them. So make sure you add that to, right there. Everything else I think people did pretty well. Let me take a picture of what I have on my calculator so you guys can see what I have, so make sure it matches up with what you have. All right, there we go. So I have the integral from -3 to 0 of y1 minus y2. That gave me 22.5. And then adding that to the integral from 0 to 2 of y1 minus y3. Notice that I changed that to the blue function. Gave me 35.833. Please make sure to round your answers to 3 decimal places. I know that it repeats itself, and so some of you guys feel like you don't need to do the 3 decimal places, but you do every single time. Put 3. I've been marking people wrong on the FRQs. Not completely wrong, but I've been marking people off on the FRQs for not rounding to 3 decimal places. So please make sure that you always do that. You can truncate or round. So do you know what truncate means? You can either cut it off, like obviously this one, the rounding and the truncating would be the same, but you can do 85.33 cut, or you could do 85.33, and then if the next round number rounded the 3 up, you could do that as well. Did you have a question?
So when you do this problem on your calculator, would it change your answer if you just, you know how you did like answer plus the new integral? Would it change your answer if you did both the integrals together?
No, unless you made a mistake.
Okay.
You mean if you put it all on the same line? So if you did this one, and then instead of pushing enter, you just pushed plus, and then wrote that, it would not change your answer, no. All right, beautiful. Let's keep going. This next one is a little bit different. So here's what we've done so far. So everybody look up here for me. At the beginning, we started super basic. We said find the area between these two curves, and they gave you points of intersection. On the next one, I said find the area between these two curves. They didn't give you the points, but it was pretty easy to tell what the points were, or you could use your calculator to find them. On this one, we wanted to find the area between the y-axis and then the red and the blue curves. So we had to find the area of this one. So again, it got a little bit harder, but not that bad. On this one, we had 2 areas. We had to set up 2 different integrals to do that. On this one, we only had 1 area, but with different functions. We had to set up 2 integrals to do that. This is the last type of area between curves problems that we will encounter. And here's why it's a little bit different. Here's why it's a little bit different. Well, let's see if you guys can tell me why it's a little bit different. Look at example number 6 for me, either up here on the board or on your paper. And tell me if you can figure out why it's a little bit different. Let's have one at a time. Over here first. Okay, yeah. So the parabola, notice that this is a sideways parabola, all right? And notice that it's split up in between two different colors. So the top half of it is red and the bottom half of it is green. Do you guys see two different equations for it up here, though? I see two different equations, but both of them are not for the parabola. Only one of them is for the parabola. Which one's for the parabola? The y squared one. Okay, so notice that on all of the previous examples, notice that it was always y equals and then it was something to do with x, right? How is this one different? It's x equals and then something to do with y. So these are functions of y rather than functions of x. So notice that everything's in terms of y now. So we have a couple things. Excuse me. To actually graph it, you have to solve for it in terms of y. So notice that if you were given this, could you put that in a graphing calculator? No. So notice it says right here, to graph it, you need to solve for y. So you'd actually have to get y by itself to graph it, which is what kind of leading back to what Thomas said again. If you solved this equation for y, you would get a plus or minus square root, which is why one of them's in red and the other one's in green. So the plus square root would be on red and the minus square root would be on green. And then if you solve this for y, you just have a linear equation there. It says rather than integrating using x, use y and go right to left instead of top to bottom. So they suggest, and I'm actually we'll do it both ways so you guys can kind of see the alternates. But they suggest actually solving for y here and then integrating from left to right. That's not my favorite way because sometimes it's easier to do it that way, but in not all cases does it make it easier to do it that way. So here's what I want you guys to do. I want you guys to take your head and tilt it to the right. Can you see tilting it to the right? Okay. Now do you see a downwards facing parabola with a line? Okay. And do you see two different areas, kind of like we did on the last problem? One with the red function on top and one with the blue function on the bottom? And then the other one with the green function on the top and the blue function on the bottom. Can you guys see that? Okay. We're essentially going to integrate according to that. All right. So here's what we're going to do. Do you have room on your paper kind of like underneath at the bottom? Maybe draw an arrow that we're going to be writing down there for a minute. Alright, so let me erase all this. And we're going to do it the actual way that it was intended to be done rather than using the little shortcut cheat way. I think it's easier. So here's how we're going to do this. We're actually going to integrate from bottom to top rather than from left to right. So remember before, do you guys remember that little simulation I showed you yesterday in class? And the ones with X went left to right and they kept accumulating area from left to right. And then the ones on Y went bottom to top and they accumulated area from the bottom up. That's what we're going to do. So now when we look at values, we're going to be looking at y values. So do me a favor, help me out. What's the lowest y value you see up here? -2. Okay, so do me a favor. Put a little point right there at that intersection and label this y equals -2. And then take your highlighter, because remember we like our highlighters. And I want you to highlight this first one. So notice that it's the green area that's on top. Remember, if you tilt your head sideways, you can kind of see that it's on top. And the blue area that's on bottom. And then I'm going to stop as soon as it switches. And actually, I lied. We're not going to stop. We're going to keep going, and I'll tell you why. You only have to stop if you're going to do their little shortcut cheat sheet way, which is actually creating 3 different equations, where you solve for y and create 3 different equations. But I don't want to do their little shortcut cheat sheet way. We're going to do the way we want to do it. So we're going to integrate the entire thing all at once, because technically we only have 2 equations. We have the parabola and we have the line. And then tell me, what's the highest y value you see up here? Y equals what? 1. So here's what I'm going to do. You guys don't obviously have to write this on your paper, but I'm going to take a picture of it and then I'm going to turn it so you guys can kind of see what I'm looking at. All right, so here's what I look at and how I kind of want you guys to look at it, even though it's not perfect. Oops, that's not what I wanted. Hold on. All right, there we go. That's how I look at it. I look at it sideways, so you guys kind of tilted your head to the right and saw it. This is what you see. So notice that the negative numbers are over here now and the positive numbers are over here, so we just have to read backwards. But essentially we're integrating from -2 and we're going to be accumulating all this area all the way to +1. All right? What's the top function here in this one? The parabola. And what's the bottom function? The line. Okay, so that's what we're going to do over here. When we write our integral, we're going to be looking at the top function, which is the parabola, or the one all the way to the right, minus the bottom function, which is our line. So here's what I want you guys to write. I want you guys to write the integral from -2 to 1, because those are my y limits, the furthest one to the bottom and the furthest one to the top. Of the top function, which you guys said was the parabola, 3 minus y squared, minus the bottom function, which you guys said was the line, y plus 1. Now notice that we're talking about everything in terms of y now. So instead of dx at the end, what should I write? dy. Now here's the cool thing. Your calculator will actually do this for you. It's just that you can't use y's, you have to use x's. But as long as your limits here are in terms of y, which ours are, y equals -2 up to y equals 1, as long as these are in terms of y, then it doesn't matter if you use y's or x's. So go ahead and put this in your calculator. It's just that everywhere you see a y, change it to an x. The first thing I'm going to show you is what I put in for my functions. I put in 3 minus x squared and I put in x plus 1. So again, notice that even though it has y's in my integral here, it's okay to use x's here just because we're just calling it a variable. It doesn't matter what variable it is, it's just a variable. And then notice that my home screen I got, and let's see if you guys got the same thing. I did the integral from -2 to 1 of y1 minus y2, and I got 4.5. Did you guys get that? Yes. All right, beautiful. So you guys should get the same thing. Notice, by the way, you could have done this by hand pretty easily. If you integrated this by hand, you could have done it without any issues, but 4.5 would have been our final answer. All right, so here's what we're going to do now. That is pretty much a summation of our area between two curves. If you notice the last problem, example 7, it just says to draw 3 points and then connect them to make a triangle and find the area of the triangle using this method. So all you would have to do is find the equations of those 3 lines and you could break up the integral and all that kind of stuff. But I would rather do some practice AP questions that maybe is a little bit more valuable and worth your time. So notice that we had mainly like 3 or 4 different types of problems today. The first type of problem we had was when we had just basic, like area or function on top, function on bottom. Here's the limits, easy. The second type was when we had to break it up into 2 integrals, whether or not it was the areas were broken up or because we had different functions to break it up along. And the third type we had was here when things are in terms of y. But again, as long as your limits are in terms of y, and as long as you correctly tell me which one's the top function and which one's the bottom function. By the way, how do you know which one's top and bottom here? Like, how did I know to turn my head to the right and not to the left? You always want the positive numbers, the positive y numbers to be on top. So notice that these are positive values. So if I turn my head to the right, I have those positive ones on top and the negative ones on bottom. So I want to do bigger numbers minus smaller numbers. So obviously if I look, for example, here, this is at 3 and this is at 1. So 3 minus 1 would give me 2, which is why I know I want to do it that way. All right. So you always would turn your head to the right for those ones. To get the correct picture there. So then this is the third type where you have to have it in terms of y instead of in terms of x. You could, by the way, solve these equations in terms of x and actually do it the old-fashioned way, but I think it was just easier to do it this way. We only needed one integral and it was super, super easy. All right, so I'm going to give you guys, oh yeah, sorry.
I'm sorry, again, how many is it divided into rather than the green?
Because the way that whoever wrote this curriculum suggested to do it is that they suggested to solve these equations for y and get y by themselves. And in this equation for the parabola, if you did that, you would have x minus 3, then divide by a negative, and then take the square root. And when you take the square root, it have to be plus and minus, which is two different equations. Yeah, but like I said, I think it's easier to do it this way as long as your brain can understand that when everything's in terms of y, you integrate from bottom to top rather than from left to right. All right, so I'm going to give you guys a problem that is on a previously released FRQ and see if you guys can do it. It's not multiple choice. You won't be able to check your answer immediately, but we'll go over it together after. So when you see it up here on the board, go ahead and get started on it. All right, so this is from the 2008 AP Calculus exam. It's number 1, so you do get to use a calculator. This question type shows up on almost every single AP exam. You are almost guaranteed to see one of these questions where they're asking you to find the area of the region. We haven't gotten into volume yet. We'll get into that tomorrow. But then they ask you to find the volume of the region as well, and we'll talk about that if it's being rotated about. So part A says find the area of the region, and it gives you which equations are which. It doesn't actually tell you which is which, but you have to figure that out on your own. So try to find the area of that region. You do get to use a calculator. Make sure to show your setup, so you can't put everything in a calculator. You actually have to write out your integral on your paper, and then we'll check it in just a few minutes. Here is what my y1, y2 look like, so hopefully your guys' look like this as well. So I put sine of pi x in for y1, and I put x cubed minus 4x in for y2. Which of those, by the way, is the top function? Sine of pi x. If you didn't know that, you could graph it. Hopefully you do know that this is the graph of sine, okay? And at the bottom one, the cubic function would be x cubed minus 4x. If you didn't know that, you could always check it, but if you did know that that was sine, that would be great. So from here, if I go back to my main screen, let me put it in really quick. If I go math 9, my lower limit is 0, my upper limit is 2, and then y1 minus y2 dx gives me 4. Did you guys get 4? Beautiful. So here's what it looks like in my calculator. Alright. There we go. So 0 to 2 of y1 minus y2 equals 4. Okay, you probably get maybe 1 or 2 points for that. I haven't looked at the scoring guidelines, but I would assume 1 or 2 points for that. Alright? Which is not bad. I mean, obviously there's a lot more to this problem, but 2 points for something that's that easy is not a big deal. By the way, when I was grading your guys' FRQs, some people, not very many, but some people like either wrote down the integral wrong or didn't write down the integral, and those definitely get points marked off. So please make sure that you guys write down the integral correctly. Notice here, notice here that these are both called y. All right, so you actually do in this case. You have 2 options. You either have to write down the integral like this, because you can't just put y minus y, or if you rename these, like if you actually renamed this like f and g, they might accept that. But I think it would be more safe to write it out as the whole integral, but if you wanted to rename them, I've heard they accept that as well, so you could do that. All right, here's what I want to show you guys really quick. The rest of this problem, we haven't actually learned how to do yet, so we're going to learn eventually how to do it, but not yet. So notice that it takes revolutions, and they're talking about volume. We'll talk about that later this week so that you guys can kind of see that. Here's what I do want to show you guys, though. What year was this one from again? 2008. Okay, look. Here is... Oops, too far. Here is 2009. What's the first question say? Find the area of R. Here's 2010. What's the first question say? Here's 2011. What's the second question say? Find the area of R. Here's 2012. What's the first question? Area of R. Here's 2013. First question, find the area of R. Here's 2014. This one says find the volume. All right, so that one they skipped over the area question. But it was part of the other ones anyway, so you have to know how to do it anyway. So essentially from 2000, I only looked up to 2008, but essentially from 2008 to 2014 on every single FRQ, you'll find this question. So it is a very important question. You do need to know how to do it, and you are almost 100% guaranteed to be asked how to do it. So I'm going to give you guys one more and see if you guys can get this answer really quick before you leave. So I want you to do, oops, not this one. I want you to do this one. Just the first part again, part A. And this is number 2, so you get to use a calculator again for this one.
Right under log. And under slash.
I'll give you a hint. You have to set up 2 integrals for this problem. All right, we're going to go ahead and finish this one tomorrow. So go ahead and pack up and we'll see you then.